Okay, good afternoon, everyone. It's 1 p.m., so we'll get started. And welcome to this joint session between DSI and the Microsoft Education team on moving from Oracle to SQL Server 2016. My name is Stephen Giles. I am the Director of Data Platform Maturity here at DSI. My email and my Twitter account are here, and I will be your presentation today. So DSI is a Microsoft Gold partner, and we focus on data, on both the data platform and on business intelligence. And part of my practice as Director of Data Platform Maturity is our Oracle migration practice, and that's really where we're coming at today. So we'll dive right in, and I just want to we're going to start by talking about SQL Server 2016 and the new features here, and why SQL Server is a viable alternative for Oracle. And then we're going to go and look at the migration process, the one that we go through at DSI. We will have a little time for Q&A at the end, so feel free to type your questions in the window, and my assistant will make sure that we get everything answered. So why don't we dive right in? So these are interesting times for Microsoft and Microsoft SQL Server. In 2016, it was the first year that Microsoft really pulled to the lead in the Gartner Magic Quadrant for operational database systems, pulling ahead of Oracle clearly. But Microsoft SQL Server is also in the leaders quadrant, both for data warehousing and data management for analytics, and for BI. So as a platform, SQL Server sits in the leaders quadrant across a number of different places. And really, it's a recognition by the industry of where SQL Server has come to. Now, this is a database system that is being used by large enterprises, both for some of the largest independent software vendors that Microsoft works with, groups like Autodesk and Esri and Bloomberg, but as well, it is being used by across all industries, certainly for tier 1 workloads. And this, I've been in the SQL Server space, well, really since the beginning of SQL Server, and we are now seeing SQL Server, well, now in the last couple of years, seeing SQL Server in those large tier 1 mission critical roles where they were not in the past. So really, where you look at some of the names on this list, are some of the biggest companies in the world, and all of them are using SQL Server to run their businesses. Now, one of the reasons why SQL 2016 is such an interesting product is really the fact that in a single license, everything is there. So we get certainly, as we saw in the previous slide, an industry-leading SQL data platform, but it is one that is highly secure, highly performant, and has a number of features for business intelligence and for advanced analytics that give a massive amount of potential at a very reasonable cost. And certainly for customers in the education space, all of these things are required, but the cost sensitivity is something that's attractive as well. So let's take a look at each of these in detail. So we'll start just looking at total cost of ownership, and these are numbers comparing SQL Server to Oracle, and where these are really interesting, and this goes back to the everything built-in message. When you buy SQL Server, you get SQL Server. You get the engine, you get all of the BI tools, you get the high availability and disaster recovery tools, all of the security features, all included in that single license. If you add a tool like Power BI on top of that, which is a per user base for ad hoc and self-serve analytics, you get a fully featured system around business intelligence, again, for a very reasonable fixed price. With Oracle, that's not the case. That every single one of these tiers is an additional cost. So if you want the data warehousing, you pay for that. If you want in memory, you pay for that. If you want disaster recovery and high availability, that's a separate module. You then add the cost of their BI solution on top of that, and the cost per seat goes up considerably to the point where you're getting a 3.5x times cost increase for the server and a 20 times cost increase for the users. Whereas with SQL Server, it's a single cost, everything's built in, and you're not sacrificing functionality just for cost savings. That it's really, you're getting parity and comparable costs, comparable functionality, but you're not paying for the difference. So I want to dive into the product itself. SQL Server 2016, the current version, has a number of new features that really do lend itself to most industries, security being one of the most important ones. And with security, there's really a number of different areas. But before we get into the features, if you take a look at the chart on the right, this is numbers put out by the NIST, the National Institute for Standards and Technologies in the US. And what they've been doing in this study is they've been tracking reported vulnerabilities by database platform. And if you look here, the orange, which you don't see a lot of, is the SQL Server, yellow being Oracle. When you compare vulnerabilities, SQL Server comes in by far the lowest among all of them. Now, we only have numbers up to 2015. We haven't seen the 2016 report yet, but you look at the trend across this going from the beginning. We have a spike in 2008. That's when SQL 2008 was released. 2009 was when SQL R2 came out, but then we go down to 0, 1, a little bump up to 4 around the release of 2012, back to 0 for 2014, and a little bump when 2014 was released. You compare that to Oracle, where you have a double-digit numbers of vulnerabilities throughout the entire time period of 2014. And an interesting statistic that came out as well. Not only does SQL Server have the lowest number of vulnerabilities, but DBAs are more likely to apply security patches to SQL Server than they are to Oracle. A study was done of Oracle databases and found that the majority of them were at N-1 or minimum for service packs. So even when vulnerabilities are identified, they're not always patched right away. So we have, in terms of just, is SQL Server as secure as Oracle? The answer is yes, or possibly more so. As far as the new features go, there are some really key things here. And again, this is all out of the box. So the ones I'll call out because they're the ones that we are working with our customers every day. There is full auditing available in SQL Server. Now, if you have any kind of compliance requirements for data, one of the things you will always be asked to provide is audits. Audits in terms of what are your administrators doing, what are your users doing. That feature is right out of the box in SQL Server. So you can monitor access to sensitive data. You can monitor when users have their privileges elevated. You can monitor when objects are created or destroyed. So all of that stuff is built in out of the box. As far as access control goes, we have full integration with Windows Active Directory. We've also, Microsoft has also in 2016 added 2 new features. We have full row-level security now. So it allows me to apply filters on my tables so that I can control access not just at the table level, but at the row level. So I may have a list of all students in a particular board, but I may want to limit the view of a particular school administrator to the school that they're responsible for. So although the table has all students across the board, when I, as the administrator of a particular school, goes in to look at that table, I just see my school's data reflected back out, which saves me of having to have multiple tables or create multiple views. I can turn on data masking or row-level security, and basically my identity and the group I'm a member of controls what I see. We also have dynamic data masking. This is a really interesting feature that allows me to return data from a table, but to hide certain features from the data. So I could, for example, and this is a very common example, I have personal and private information. So birthdays, social insurance numbers, credit card information. I may want to return a record, but I may want to mask out certain values so that birthday just shows my year of birth, or my credit card just shows all X's and the last two digits of my credit card, something like that, where the person who has access to the table needs access to the record as a whole, but doesn't need access to that particular piece of information. This gets put on as a policy, and once I set that, everyone who is given access to that table has that mask applied to them. And this way they I don't have to worry about, am I controlling each individual person? I set the policy; it applies to everybody evenly, unless I specifically go in and exclude someone. So, going back to the customer record, I may have a table of customer information that has credit cards in it, and if you're just a customer service representative, you look at that record, you see the credit cards X'd out except for the last two digits. But if you are in the finance department, I'll exclude you from that policy. And when you go and look at that record, you'll actually see the full credit card information. So if you have to process payments for that individual, you have been authorized the right to see it. Now, that data is always in the database, correct? So I'm not storing mass data in one place and unmasked data somewhere else. I have one master record that has that data stored, but unless I'm a member of that group that was granted the exception to the policy, I can't see the data that's masked. So these are really useful just in controlling access. It gives me a much more granular level of control over who can see what, when, and where. And then the final piece to this puzzle is the data protection piece. And this is really key. There is a lot of concerns now around things like encryption. So transparent data encryption, which we've had for a while, allows me to encrypt entire databases or entire backups. SQL Server has also added a new tool called Always Encrypted for organizations dealing with a lot of personal and private information, particularly if they're considering moving to the cloud. Always Encrypted gives me a really interesting functionality where encryption is moved from the server to the client itself. So my client makes a request. That request gets encrypted by the Always Encrypted libraries. And what gets sent across the wire and to the server is the encrypted hash value. Now, in this case here, we have a social security number where my user actually types in the SIN number, but what goes across to the server is a hash. Now, one of the things I can do with Always Encrypted is I can store that ciphertext as actual data in the table. So not only is this encrypted going across the wire, but it's encrypted when it's stored as well. So that value is there. I can actually search against it. So in this case, we're using it in the where condition. I can put an index on the ciphertext if I want. And then when the record is returned, Always Encrypted takes the hash value and it converts it back to the actual value and presents it back to the user. So this means, as I pointed out, on the round trip, the only time the data was visible was on the client application. Once it was sent, or from the point it was sent from the client to the point that it came back, it was always in ciphertext. So if we're moving data to the cloud and we're worried about data encryption in motion, encryption at rest, Always Encrypted is a way to get that functionality, and that's something that's new with 2016. The next piece really is the performance, and you'll hear, and I still hear it from some of my clients. Well, SQL Server just can't handle the volumes of an Oracle or similar database. If you go and look at the actual metrics, that's not necessarily the case. Now, these are coming from TPCH metrics. These were the slide, they were pulled in 2015. In 2016, SQL actually performed better, but the TPCH, which is the processing test for data warehousing, of the top 20, 10 of them were SQL Server, including the top 8. So in terms of just comparing SQL against other vendors in the marketplace, and you can take the TPC reports for what they are, but they are comparing apples to apples as far as each vendor tweaking their servers to best performance. SQL Server is still performing in the top of that heap. We're also seeing this for large hardware settings and for very large workloads like SAP. SQL Server with Windows 2016 Server can use up to 12 terabytes of memory and can go to the physical limits of cores on the server. So we can get very large boxes if we need to, and SQL Server will support the large scale. One of the other things built into SQL Server and really perfected in 2016 is the in-memory features. And really this allows me to greatly increase performance by running key tables entirely in memory, both at the row and column level. So, excuse me, if you look at the past, so let's say I have a system for tracking point of sale. In previous iterations, my POS system would stream back to a operations database. I would then have some kind of ETL process that would move that data into my warehouse, and then I would run my analytics against the warehouse. Now, the lag here could be whatever the ETL time window is. So it could be an hour, it could be 2 hours, it could be a day, it could be a week. If I am trying to detect fraud patterns as they're happening, being 2 to 24 hours out of date is not helpful, because the person who is actually performing the fraudulent transaction is long gone before we ever get to find out. What in-memory allows me to do is to take that same transaction but load it into an in-memory table where we have both an in-memory column store and in-memory online transaction processing. And I can then run those complex models against my actual production data in real time, and get my speed considerably faster, not stress out my production box by running queries against it, which was really the reason for going to a data warehouse in the first place, and really get close to that promise of real-time business decision-making, where because I'm looking at production data as it happens, I can actually flag problems, on the fly, and I can solve problems before they start. And really, of all the performance features that we work with in SQL 2016, the in-memory one is really driving a lot of the functionality and the functional benefits we're getting from SQL Server. One of the other places where SQL Server has really gained benefit is in their interrelation with the Microsoft Azure cloud. We're going to talk about some of the other cloud features in a minute, but one of the new features in 2016 that is really of key interest to a lot of users is what's called Stretch Database. And Stretch Database allows me to take very large tables where I have a small amount of live data and then a bunch of historical data, and I can actually stretch that data out to the cloud so that the older records go into the cloud storage, the warm records stay local. But if users run a query and that record is either in the cloud or on-premise, or both in some cases, the query will return that data. So the applications are unaware of the fact that this database is being stretched into the cloud, but I am offloading a large amount of my storage to a lower cost cloud storage, and still getting the full performance of my SQL Server. And we can use things like Always Encrypted to make sure that that data, when it goes up into the cloud, is encrypted. And we get the benefits of offloading the expensive local storage without having to make any changes to our applications. So really, there's some very interesting patterns around leveraging the cloud with SQL Server 2016. One of the other areas where SQL Server 2016 really has increased their functionality greatly is in the area of high availability and disaster recovery. So this is one of the areas where cost efficiency comes into play when we compare with Oracle. And what we have with Microsoft's high availability and disaster recovery tool, which is called Always On, is the ability to take a primary database, create multiple synchronous replicas of it in my data center across data centers. So if I have a local site and a DR site, I can have my production database both replicate locally and replicate to the DR site at the same time, and Always On will manage all of that. I can do things like take backups from my secondaries. I can offload reporting to my secondaries with SQL 2016. I can offload reporting to multiple secondaries, and I can get a round-robin load balancing of queries across the various copies. And again, with the integration with cloud, I can take some of my secondaries and I can actually push them up into the cloud. So even if I don't have a remote disaster recovery site, I can leverage the Azure cloud as my remote disaster recovery site and have Always On automatically fail over to those cloud locations if needed. In terms of questions around things like RAC, is this a full 100% replacement of RAC? Not exactly. Does it manage a lot of the offloading of workloads and a lot of the disaster recovery that RAC does? Yes, it does. And certainly with our clients, when we have that conversation around RAC, we always start with, well, what exactly is it that you're trying to achieve? And can we achieve the same service levels in SQL Server, possibly in a different way? And certainly with Always On, we can do a lot of that kind of offloaded processing. And there is a case study you can see on the Microsoft website, but Lufthansa leveraged the Always On, gave 35% operational efficiencies and at a reduced cost. For those who are doing data warehousing as a workload, SQL Server can handle that both on-premise and in the cloud. we can SQL Server itself, because of its ability to scale up, can handle fairly large data warehouse loads. But when we start getting into the very large scale, we have two options. On premise, we have APS, the analytics platform system, and in Azure, we have something called Azure SQL Data Warehouse, which is a tool that allows me to build massive multi-scaled data warehouses as a service. Azure Data Warehouse is actually a very interesting tool, and one that we're working with a number of our clients, where storage is decoupled from compute. So I can push terabytes and petabytes of data into this thing if that's what I have. Storage in Azure is very inexpensive. What tends to be more of the driver of cost is the compute time. Because compute is separated from storage, I get all the features of Azure Data Warehouse, but I can dynamically scale the storage, or sorry, scale the compute up and down as I need it. So if I know I'm going to do some very heavy-duty reporting, or my data scientists are going to go in and really run some complex models against the warehouse, I can bring my compute up, and then when I'm done, bring it back down, and I only pay for what I use. And if my data warehouse is being used to process cubes, for example, only, I can actually bring it right down, and then I only pay for the storage while it's down. So a lot of functionality there as well, but you get all the benefits of SQL Server with it. One of the interesting places where SQL Server is making advances in the BI world is in the integration with big data. I'm starting to have more and more big data conversations with my customers, a lot around the use of or the inclusion of unstructured data combined with structured data. So, we'll take an example here, one that everyone's familiar with. This example comes from the insurance industry, but where we have a bunch of relational data, so in this case, policyholders, but we also are collecting heavy streams of telemetry data from vehicles, and all of that is going into an unstructured data store on Hadoop in this case, but it could be Data Lake or one of the other tools. And rather than doing the old school traditional ETL import of all of that unstructured data into the warehouse, which it's a massive amount of data, it's a huge storage cost. Instead, we leave it in the unstructured storage system, and we use a tool called Polybase to run queries from within the SQL Server and create external tables pointing to the unstructured data. I can then write queries that combine my structured data and my unstructured data. So in this example here, we could pull up the policy information, so I can get your age and your marital status and the kind of car you drive. So that may be part of the equation for what rate I set for you. But I can also then run an algorithm against the data that I've pulled from the telemetry and get some kind of a score as to how safe a driver you are, and that gets factored into the rate that you get as a potential customer and the quote that comes back to you. So all of this gets integrated together without me having to actually import all of this unstructured data into my SQL Server database. One of the other areas we're seeing a lot of as well, and I'm seeing this with one of my clients where they're dealing with educational organizations that are sending data to them. All of it is coming in JSON structured flat files because all of the different schools are using different systems and platforms, but all of them were able to export into this format. SQL Server has the ability to parse and read those JSONs as well. So we're seeing more and more of these non-traditional, non-relational data sources coming into play, and SQL Server, rather than forcing you to convert all of those into an old school normalized relational database, it allows me to work with those features where they are. You couple with that the addition of R into SQL Server. So Microsoft in the 2014 timeframe purchased a company called Revolution R. Revolution R has been integrated fully into SQL Server as SQL Server R services. So what these services allow me to do is they allow me to do true advanced analytics using R natively within my SQL Server. I can also embed R code into my Transact SQL queries. So again, I may have my analyst create some kind of a propensity score, and I can write a query that says, execute some Transact SQL to pull some specific records out of a table, but also call a block of R code, generate this propensity score, and return that as one of the values in the query. So without having to cool and do one thing and then into the database and do another, I can do all of that at the same time. And again, all of this is included in the licensing cost for SQL Server 2016. So it's not a separate product. It's not a separate SKU of SQL Server. It's really just, you buy Enterprise SQL and the R services are there. Yeah, so you couple the R services within memory, and this goes back to the example I gave earlier of running real-time analytics against live data. So in a traditional all-on-disk world, that was really hard to do because the advanced analytics would usually bring my production system to a halt. Within memory, that now becomes an option that I can actually perform in real time these complex calculations against production data. So I want to talk for a minute about the advantages of Azure with SQL Server, because you can't really decouple one from the other. And this, there's a couple reasons I want to bring this up. This cloud-first approach, has actually improved not just the Azure on-premise version as well. So I was talking to a product manager from Redmond on the SQL team at an event, and he mentioned to me that in earlier versions of SQL, everybody would run n-1, or at least wait till Service Pack 1 or 2 came out, because what would happen was develop a feature. That development would go into an 18-month development cycle. It would then be released with the product, and it could be another 12 to 18 months before they got enough feedback from the user community to find bugs with the features, to determine the viability of the features. So really, they were looking at a 24 to 36 month cycle of come up with an idea to getting actual feedback on how it went. What's happening now is that these features, as soon as they're ready, are being released into the Azure world, so into SQL Azure, into Azure SQL Database. And rather than on an 18-month cycle, these things are on a 2 or 3 month cycle. So these enhancements, they get released faster. There's no longer a need to aggregate all of these fixes and wait for the next big product release. So always encrypted showed up in SQL Azure before it was ever released in 2016. Dynamic data masking, the in-memory features, column level security, all of this stuff or row level security, sorry, showed up in the cloud months before the release of SQL 2016. So by the time SQL Server 2016 launched, most of these features had been through months and months of live user testing. And the feedback had gotten back to the development teams, and fixes had been made prior to release. And really, what we ended up with was a version of SQL Server and SQL Server 2016 that was much more stable than any other version of SQL Server that had been released, because all of the features that were new to this version had been pretty much battle hardened, over the last 6 to 12 months. By constant feedback from users actually using the features in Azure. And then, the code goes back into both. And so the cloud version and the on-premise version have parity of features, but the on-premise version is now being driven by the cloud version. And I think this is what's really interesting. The other thing too, and I know that a lot of educational organizations are looking at the cloud from a cost perspective, but they're concerned about it from a compliance and security standpoint. And the advantage here is that Microsoft's vision is really cloud first, but not cloud only. So you can leverage cloud where it makes sense. You can ease into it as your compliance testing and whatnot catches up to it. And here are some examples of where the awareness of on-premise SQL Server of the cloud can give you real benefits without having to move your entire workload into the cloud and to get a true hybrid scenario. So the obvious one really is just backups. So I can run my SQL Server on-premise, but I can use the Azure cloud as my disaster recovery site, or my high availability disaster recovery site, by basically running my backups locally but pushing them into the cloud. So cloud storage is often considerably cheaper than on-premise storage. I don't have to worry about my SANs and my NASs filling up. And I gain other advantages as well. So storage in Azure can be geo-redundant. So I can have a backup to a local data center, but I can have it geo-redundantly replicated to another data center so that I'm protected if I have trouble on site or if my primary DR site goes down. So also, once stuff is in Azure, if I have real problems on premise and need to stand up a SQL Server quickly, I can actually stand up a VM in Azure, and because my backup's already there, I can restore that backup to that VM and get a server back up and running. It does reduce CapEx because really, I don't need to buy a bunch of cold storage or cold servers sitting around. I push my data into Azure. I only pay for consumption, so I'm not buying a large storage array in the anticipation of filling it at a later date. I only pay for what I push up as OpEx rather than CapEx. And if I do need to do something like stand up a VM in a disaster recovery scenario, I only have to worry about the VM when I go to actually stand it up. So there's no real provisioning. I just go into the portal, I say I need a VM, 15 minutes later I have it, I restore my backup, and I'm up and running. We also mentioned doing DR. So with Always On, I can have my primary database running on premise. I can even have synchronous secondaries running on premise, but I can, across a VPN tunnel, stand up a virtual machine in Azure, have SQL Server running on it as an asynchronous secondary, which means that I have an off-premise site, DR site, sorry, where my SQL Server is up in the cloud if I need it. It's across the VPN, so all of the communication is encrypted and secure. I can run my backups off the cloud run. I can even run reports off of my cloud secondary if I want to. but this is really a closed network. Now, I've built an environment like this for a law firm that was really concerned about security and access. And what we ended up doing was building a model very similar to this, but closing all the external access to Azure off. So there's no public IP for any of the servers there. The only way to access the secondary server is to make a Citrix connection into their on-premise environment and go across the VPN up to the other server. So they gain the cost advantage of offloading a lot of this work to the cloud, but they've still, all of the security features that lock down their on-premise network were being extended to those objects we'd put up in Azure, because that was the only way you could get to them. There was no public interface in the cloud to get to those servers. You can also do bursting to create a full extended environment where I have some SQL servers on premise, some SQL servers in the cloud. And the cloud, and this goes back to my example of the law firm, the cloud just becomes an extension of my data center, but an extension where I can bring servers up and down as I need them. I don't have long hardware procurement cycles. It's pretty much pay for use. But I can have the full extension, so I can have my domain up there. I can have everything up there. So it's quite a solution, and SQL Server is fully cloud aware. So let's turn and talk to the migration process now. The migrating from SQL Server is it's a challenging task sometimes, but it's not if it's taken with the right precautions, it's a very workable solution. And there are a number of tools to help us out. So this is a process that we follow. We usually go in and do an assessment first. The assessment involves looking at the Oracle server, understanding it, looking at the application landscape, making sure that the applications will run against SQL Server, or in some cases we have clients who are in the space looking to replace one technology with another. So I am working with one of the colleges right now to look at moving PeopleSoft from PeopleSoft running on Oracle to PeopleSoft running on SQL Server. And I've worked with other customers who are looking at things like moving from Oracle CRM to Dynamics CRM, for example, where the actual migration of applications is not as important because we're actually going to switch over. So we always start with the assessment. The assessment is important because it tells me what is my work effort, where are the potential landmines, what does my application landscape look like, what issues am I going to have in the migration, what will have to be manually rewritten, what can be automatically scripted out. We then go into a design phase where we come up with a potential solution, and then once that's approved, then we go into the migration, and we go into a cycle of migrate, validate, test, and then move over again. So we tend to move things in chunks. So we'll take individual Oracle schema. We'll move all the objects in that schema from Oracle to SQL Server. Then we'll move all the data across. And then we'll do validations against the data. We'll then connect the applications. We'll test the applications. If there are problems, we remediate. If everything's fine, then we move on to the next chunk, and we cycle through this until we get everything moved up the way we want. Once everything is there, we know the apps work, we know the data is correct, then we pick a final date, we freeze access to the Oracle server, we do the last minute migration of data, and then we push off for deployment. And there are a number of tools to help us here. On the assessment side, two tools that we use. One is the MAP tool, the Assessment and Planning Toolkit. MAP allows me to go out and look at my environment, It allows me to find my Oracle servers, find out, what hardware they're running, how much memory they're using, how many databases, how many objects. We also just tend to run a bunch of queries against the Oracle servers themselves, and we end up building what we call an object migration list, which is basically a list of everything that's in the Oracle server, and then we start assessing what needs to move and what doesn't. The tool that we use the most is the SQL Server Migration Assistant. And SSMA is a really powerful tool because what it allows me to do is take an existing SQL or Oracle object, whether it's a table or a view or a package or a procedure or a function, and run it through a tool that identifies potential challenges with the migration itself. So what we end up with is a report. That report looks like the one that's on the screen here. And it shows me which objects can be automatically converted, which ones cannot. It gives me a cost estimate. It also gives me conversion details. So if I get an error, it'll actually go and tell me what the issue is, and I can go in and see the Oracle code. So if I have an Oracle procedure that gets flagged as not automatically convertible, it'll show me exactly what the problem is. It'll show me why it can't automatically migrate it, and it'll give me a work effort for how long it'll take to manually make the change. And the work effort here tends to be fairly accurate from our experience in terms of just how long things take. And why we do the migration assistant, the object migration list first is that I only want to test things that I know have to move. So there may be a whole bunch of stuff in the Oracle database, personal schemas, and support for objects that are or applications that are no longer being used. We take all of that out of the consideration first, and then we run SSMA against the things we know that have to move. And what it really does is it tells us where the problems are going to be. It shows us what percentage of objects will move cleanly, what percentage won't. We use this to come up with the work effort of the actual migration itself, and the estimation of timing and cost. And then when we actually get into the migration itself, SSMA will generate the schema objects for me. So I can actually go in, choose my type mappings, make fixes to code, store it within the SQL Server Migration Assistant, and it'll actually generate all of the schemas for me, move the schemas themselves. SSMA will move data, but I don't like to use it for large data movements. For small movements, I will, but it's not very efficient. For large-scale data movements, we tend to use things like SQL Server Integration Services, where we can do mapping and transformations on the fly. We can batch very large data sets. We have a lot more control over the movement of data. But all of these tools are here to really make it easy to do the migration. And these tools will reach back into older versions of Oracle. So if you're still running 9i or 10G in your environment, we can still go back and look at your data. And again, the migration is a two-step process. One, we migrate the schema first. So we make sure that all of the objects go across, all of the tables, all of the views. We make sure that we get our data types mapped correctly. If there is manual rewrites that have to happen to the code objects, we do it. And then once the schema is there correctly on SQL Server, then we do a straight data migration from Oracle into SQL Server, and then we do our testing against the migration. So we do row counts and checksums and all of that automated testing, and then we pass it over to user testing to identify, the occasional hiccups in terms of just data from A didn't go into B cleanly. But once the schema is locked, then we just move the data as needed. So that's the end of my content. We're going to open to questions in a second, but before we do, I just want to point out SQL Server is a very viable solution to Oracle. Certainly our customers, we have a number of customers who are making that choice. The evaluation and the assessment is the most important part. You never want to enter into a migration blindly. You want to know, am I going to have application issues ahead of time? You want to know, am I going to have huge schema rewrites, or can everything move over cleanly? You need to spend a little time thinking about what has to go and not go. And we certainly have some offerings in market right now that we can assist you with. We do have a 1 day and a 5 day Oracle migration workshop. The 1 day we'll just come in and really talk through Oracle in your environment and what the migration process looks like in detail. We'll let you see SSMA and work with it. And the longer term engagements will actually come in and do the assessments for you if that's something you're looking for. So, I'm going to open the floor to questions now. We've got 10 minutes left, but certainly if there's any way we can assist you, we're happy to do so. So, Amanda, are there questions sitting in the window right now? Do you want to take people off mute and people can ask their questions if they want? So we'll take you off mute. Please feel free to ask your. And if there are questions, I'm certainly happy to entertain them now. Okay, so I hope that I've helped you address the reasons of going to SQL Server and also just talk through the Oracle migration process. There are certainly some clear benefits for those who are looking to gain the most efficiencies out of their data platform, both from a cost and usability perspective. And really, SQL Server as a platform meets both of those needs, and there is a clear path from Oracle to SQL Server, and we would and Microsoft would be happy to discuss this with you. So if there are no questions, we'll close out the session now. But please, if you do have questions afterwards, reach out to your Microsoft rep or reach out to myself, Stephen Giles, or sgiles@dstrat.com. And I thank you all very much for giving us an hour of your afternoon today.